Okay, good morning. We hope that it's now recording. I'll check it later.
Mic check. Figaro.
Alright. So you are working on the bell ringer. And you're only asked to
What is five?
interpret the 8 interpret the
I don't know what 5 is.
Okay. Here we go. And can you get out your work for me, please? Worksheet 1A.
I know what 4, 7, 8, 11.
4, 7, 8, and 11. Alright, good job, thank you. Very good. Randy is still out.
Yeah, he was kind of right this morning. I mean, he's sick. He didn't get it. Yeah, no, he didn't get it. Yeah.
She just went to nothing.
That's It's gonna be black and cream whenever I can. Black and cream.
Monty, were you out? No, you were here. Who am I thinking of? Oh, Rison.
Yeah, no, there's no finish because it was supposed to be a rock. I got it. It's not water, it's not UV. And it'll mess it up if I don't or water. It's just a little force feed. It is for
Okay, Marissa, you were out. Did you get a note this morning? You don't know where it is? Okay, keep looking. Excuse? Okay. Alright guys, here we go. So you're asked to interpret the 8 and the 5. Let me read the problem to you. This is our bell ringer. Everybody picked up one of these pages? Alright, so it says data was collected on the yearly rainfall and the corn production per acre. The data can be modeled by the equation. The variables they've used have been meaningful variables. C is corn. C is the corn production in bushels per acre. C equals 8R plus 5, where R is the yearly rainfall in inches. So can you interpret the 8 and the 5 for me? What is the 8? Okay, good. So you were told that this is the rate, and remember slope is the rate. Okay, the change in Y, we're changing X, the rate. In this case, guys, would be the yearly rainfall in inches. So we can say that they received, so these farmers received, I before E except after C, received 8 inches of rainfall that year. Evidently it's enough for corn. From what I understand, corn doesn't need much rain. So what is the 5? The 5 is the y-intercept. Now, the y-intercept is the point on the y-axis where we have a value in y, but we have a 0 in x. So let's go back and let's revisit what exactly is the x, what exactly is the y, what exactly is the input, what exactly is the output. And that way this will kind of come into play. So when I said input, what I'm asking you to find for me is what happens first in this scenario? Your two variables are that you get yearly rainfall, and then after that you have a corn production. But the input, the independent variable, is what happens first in this scenario. So what has to happen first in that scenario? Do you automatically get corn? Or do you have to get a little bit of rain first? You're going to have rain first, okay? So our independent variable, the x variable, is representing the rainfall. And then as a result of rainfall, you have what? Corn. All right, so now hopefully you can interpret the 5 for me. So you're going to have, and by the way, the C is the corn production in bushels. So this is corn in bushels, pretty much. So what does the 0-5 order pair tell us about 5? That with no rainfall at all, you still will actually produce, your corn production will actually still be 5 bushels per acre. Okay, so let's write that. With no rainfall, that's represented by the 0, with no rainfall, the corn production will still be 5 bushels per acre. You're going to get no rainfall at all, but yet you will still have a yield of 5 bushels per acre. And that's what the 5 is. Okay, now why, once again, did we say that how did we know that it was a 0-5 ordered pair? It's the y-intercept. All right, let's add that right here. The 5 is the y-intercept, the point where this linear equation crosses your y-axis. The ordered pair for the y-intercept is 0, 5. 0 is your rainfall, so with no rainfall, we still have a corn production of 5 bushels per acre. All right? Okay, good deal. Thank you. Now, let's check that homework. So we started our right triangle unit. Your homework, you just had a little bit of work on 1A. We did 4, 7, 9, 11. Very good, and you guys had it, so good job. All right, let's check those answers. So on number 4, hopefully you said that the cosine of theta was 8/17. The sine of theta was 15/17. The tangent, which is sine over cosine, was 15/8.
Huh?
Y'all are looking at me like I'm crazy. Is this not right? Oh, okay. Now the reciprocals are, for secant, the reciprocal is 17/8. The cosecant is 17/15. And the cotangent is 8/15. Okay. Are you kiddos okay? Okay, let's keep going. Here we go. So in number 7, hopefully you said that the cosecant is the reduced fraction 4/5. The sine of theta is 3/5. So once you started reducing these, did you guys realize that this was actually a 3/4/5? It was actually a 3/4/5, and we do completely reduce all those fractions. The tangent is 3/4. The reciprocal functions are secant, just invert your fraction, 5/4. Cosecant, 5/3. Cotangent, 4/3. And then on number 9, we do also want to reduce this. It also was a 3/4/5. Once you reduce those first, the cosine and sine, you realized it. So the cosine of theta reduced is 4/5. The sine of theta is 3/5. Your tangent is 3/4. Secant was 5/4. Cosecant 5/3. Cotangent 4/3. All we did was flip those fractions. And finally, number 11, again 3/4/5. Cosecant 4/5. Sine 3/5. Tangent 3/4. Reciprocal secant 5/4. Cosecant 5/3. Cotangent 4/3. Perfect paper. All right, good job, guys. Very good. Okay, please remember to reduce. All right, now, what's neat? If you look at this handout, you'll notice that some of the problems actually have radicals, and we didn't have time Thursday to get to the radicals, so let's go back and do those. All right, so I need you guys to join me on number 5. All right, worksheet 1A. These are your right triangle ratios for cosine, sine, tangent, and reciprocal ratios. All right, today is Monday, the 27th, the last week in January. All right, here we go, guys. Let's start with number 5. I like drawing the triangle so that I can refer to it quickly on my notes. All right, so we have right triangle. The shortest leg is 8. The second leg is a 16 square roots of 2. And our longest leg is 24. If it helps you, write those measurements from least to greatest. 8, again, is the smallest. 16 square roots of 2 is the medium leg, middle leg. 24 is your longest leg. And then when we label it, the first thing we're going to do is we're going to identify those parts. All right? With respect to theta, which is located right here, all right? Which one did we always identify first, just because it needs to be the one that jumps out at you? The hypotenuse, which is always opposite your right angle. The longest leg is the hypotenuse. So the 24 is the hypotenuse of this right triangle. Now, we always identified what next? Just because it's the next obvious. What do we do next? Opposite. Yes. Your 16 square roots of 2 is the opposite leg. And then the only thing that 8 can be is the what? Adjacent leg. If you are adjacent, you share a side. All right, or a vertex, and they do. Theta shares a vertex with this leg. All right, so 8's adjacent, 16 square roots of 2 is opposite, 24 is the hypotenuse. And so after that, guys, it's just a matter of knowing your ratios, memorizing those ratios. All right, so here we go. Let's start with the cosine of theta, and let's write it out until I know that you guys have it without any doubt. Let's write it out every time. Here we go. What is cosine? Adjacent divided by hypotenuse. All right, and all you do now is just place those numbers in. So adjacent is 8, hypotenuse is 24. All right, and you just learned on your homework last night we're going to reduce all our fractions. So 8 over 24, top and bottom is divisible by 8. So is that 1/3? Cosine is 1/3. All right, here we go. The sine of theta. Let's write out what it is. What is it? Opposite over hypotenuse. The opposite side is the 16 square roots of 2. The hypotenuse is 24. Now, the square root of 2, you cannot do anything else with. You can't simplify it. You can't do anything else with it. But we need to reduce the fraction. 16 over 24. Top and bottom are both divisible by 8. Thank you. The largest number we can divide into 16 and 24 is 8. Divide by 8. Divide by 8. And we get 2/3. Good job. Thank you. Very good. So 2 square roots of 2 over 3 is that answer. All right. Good job. Tangent. Let's talk about something real fast. If your cosine and your sine ratios have the same denominator, and they do because we reduced them down to 3. If they have the same denominator, then all you have to do is just take your sine numerator and your cosine numerator. So the sine numerator divided by our cosine numerator. Tell me what those are. The sine numerator's what? 2 square roots of 2. And then what's your cosine numerator? Is it 1? So that makes the tangent 2 square roots of 2 with an understood denominator 1. Okay, that's a little bit easier sometimes than to look back up and to do opposite over adjacent. You would have gotten the same thing, all right? Okay, now, can you remember what is the reciprocal of cosine? Secant. Good. All right, here we go. Can you give me the secant value? 3. Thank you. Invert the fraction. Good job. All right, what is the reciprocal of sine? CSC or cosecant. Good job. Very good. Cosecant. And the reciprocal. Okay, I need you kiddos tuned in right here. This is where the radical is going to be inverted to the denominator. If you're looking at that ratio for sine, the 3 goes up, 2 on a square root of 2 goes down to the denominator. Okay, so everybody perk up and everybody pay attention. So we don't leave radicals in the denominator. The process is called rationalize the denominator. We have to rationalize this denominator. So in order for you to turn a square root of 2 into a rational number, you simply multiply it times itself. So we're going to multiply in the denominator, you're going to multiply by square root of 2. And when you multiply the denominator by square root of 2, you have to multiply the numerator by square root of 2. It's the multiplication property of equality. What you do to one, you do to the other. All right, now the whole point of multiplying by a square root of 2 is now this is a square root of 4. But a square root of 4 turns into a nice, pretty rational, because what is the square root of 4? 2. Okay, now let me do some highlighting. Make sure in the denominator you have this square root of 2 sitting up front. And then when you multiply by the square root of 2, you created another 2 right there. It's going to make mud, isn't it? So we have a 2 that needs to multiply the 2 we created. So in your denominator, you have 2 times 2. So what do you have if you have 2 times 2 in the denominator? You actually have 4, right? Now the numerator, it had a 3. It gained a square root of 2. And that is totally simplified. You can't do anything with that. So now we have 3 square roots of 2 divided by 4. Well, all we do is rationalize our denominator, pretty much. All right, we're going to have to do the same thing on our cotangent. We're going to have to do the same thing on our cotangent. Here we go. All right, so look back up to your tangent and give me the reciprocal. What's the reciprocal of our tangent? 1 goes up, 2 square roots of 2 goes down. Okay, here we go. Let's do the same thing. Rationalize your denominator by multiplying top and bottom by what? Square root of 2. What you do to the denominator, you also have to do to the numerator. So multiply top and bottom by square root of 2. The square root of 2 multiplies the square root of 2 deliberately. You did this so that that would make a square root of 4. And square root of 4 is 2. But don't forget that you had a 2 under there to begin with. You have that 2 and you have the new 2 that need to multiply. So what do these make when they multiply? 4. All right, now look up to the numerator. You have a 1 that was already there. You're multiplying by square root of 2. And so that simply makes what? Square root of 2. Now don't simplify this fraction. You cannot simplify a square root of 2 with the 4. Don't cancel that and tell me that that's 1/2. That square root of 4 is that square root of 2, is actually like a 1.4 something another. That's actually what his value is. You can't cross out a 1.4 with a 4. You can't cross out anything unless they both can be divided by the same factor. So don't try to cancel a square root of 2 with the 4 just because the 2 and the 4 can be divided. One is under a radical and the other is not. So square root of 2 over 4 is that answer, okay? All right, here we go. Let's do another one with radicals. Look at number 6 for me. It's not going to be so bad once you've done a few of these. All right? Okay, let's draw the triangle for starters. And I'm going to go ahead and rotate it so that it runs horizontal with my paper. So short leg is 7. Middle leg is 4 square roots of 2. Hypotenuse is 21. I'm also going to write those out from least to greatest 7. Followed by 14 square roots of 2, followed by the hypotenuse 21. Okay, our theta is located right there. Okay, here we go. What leg do we always identify first? Hypotenuse, which happens to be 21. Yes, good. Hypotenuse is 21. All right, what leg do we identify next? Opposite. Opposite is the 7. And finally, the adjacent leg is the middle leg, the 14 square roots of 2. All right, here we go. All right, so let's write it out. What is cosine? Write it out every time. Adjacent divided by what? Hypotenuse. Adjacent divided by hypotenuse. All right, now just place those numbers where they belong. The adjacent side is what? 14 square roots of 2. Good job, thank you. Hypotenuse? 21. Can you reduce? What fraction is on the square root of 2? You can divide top and bottom by 7. Yes, you can. So divide top and bottom by 7, and what do we get? 2/3. So we have 2 square roots of 2 divided by 3. That's our cosine value. All right, the sine of theta. What is the ratio for the sine of theta? Do you guys know these, or are y'all just... Okay, you're just letting me do it. Okay. Opposite over hypotenuse. The opposite side is the 7. The hypotenuse is the 21. Again, we can divide top and bottom by 7, and that is 1/3. All right, tangent. You can use opposite divided by adjacent, or if your denominators are the same, you can simply just use the numerator of your sine answer and the denominator of your, and the numerator of your cosine. So your two numerators, what's the numerator of sine? Is it 1? What's the the numerator of your cosine? Is it 2 square roots of 2? All right, you know what? Here we go. We're going to have to rationalize this denominator. Is everybody clear on where these numbers came from? Is everybody good with that? Okay. All right, here we go. You ready? Can you help me? Tell me what to do. Just multiply top and bottom by square root of 2. Yeah. All righty. So in the numerator, we get a square root of 2.
Isn't it 14 square roots?
Can you go straight to my answer in my denominator? What do you get when you multiply the square root of 2 and square root of 2? Is that 2? And then what happens when you have a 2 with the radicals? 2 times 2 is 4, okay? And you're not going to try to reduce this, are you? You can't reduce the square root of 2 with the 4. Square root of 2 is actually a 1.4 if you put it in your calculator. Alright, so there we go. That one's done. Okay. Eli, are you okay? Because I was hearing you say something about...
I didn't.
Alright, let's do something real fast. Let's go back and let's do opposite over adjacent. Go back to your triangle. What's your opposite side? Is it 7? What's your adjacent side? 14 squared root of 2. What does this actually reduce to? Didn't it actually reduce to that?
Yeah, I didn't realize you reduced until I looked at it this time.
Well, if you use the sine and the cosine numerators, it will already be reduced. So when you reduce these two, then that one will be reduced. Now, we still had to rationalize the denominator, but that's okay. Okie dokie, here we go. Y'all ready? All right. What is the reciprocal of cosine? Secant. All right. Can you look back up and can you invert that fraction for me? Okay, somebody give me this. All you have to do is invert it. 3 goes up. 2 square roots of 2 go down to my denominator. And what have I got to do again? The same thing. So you rationalize your denominator by multiplying top and bottom by square root of 2, multiply top and bottom by square root of 2. Can you give me this answer like,
3 square roots of 2 over 4.
there you go, 2 square roots of 2 over, did you say 4? Good job. Very good. All right, what is the reciprocal of sine?
3. Oh, wait.
Cosecant of theta, and somebody just said 3. Good job, because you just inverted the fraction. And finally, cotangent. Okay, I want to talk to you guys about something. I want to make you thinkers. So cotangent is the reciprocal of this answer. Now be a thinker for me. These two are actually the same answer. These two right here are the same thing. Our cotangent answer is simply the reciprocal. So do we want to flip this answer and use it? Or do we want to flip this answer and use it? We want to use this one. You want to flip this one. You want the radical to be up in the numerator. You don't want a radical in the denominator because that's just going to add more work. You can flip either one of them because they're both the same thing. They have the same exact value. They just look different. So we want to flip this one because that way all we have to do is put 2 square roots of 2 up and then the 1 goes down and that is 2 square roots of 2. If you had flipped the other one, you would have had to rationalize the denominator again. So we're going to flip the one that does not have give us a radical in our denominator. Okay? All right, now, here we go. Flip over to 1b for me. Flip over to 1b. This is exactly the same thing we're doing, except there is a little more work. Kind of put a hint on number 1 for you. Yes. Okay. So notice we're doing the same thing. Everybody see? But look at all the triangles. Missing hypotenuse. Missing hypotenuse. Missing hypotenuse. Ah, look right here on number 5. Missing middle leg.
What are all those other little things, like the symbol?
Those are your angles. That's the angle we're looking for. They're not using theta. They're using beta. They're using alpha. They're using, I think this is gamma. Not real sure on that one. I'll have to look that one over.
Why are they
They're, because that's what you can use,
So it's still
different
the
Greek
same thing.
letters. Notice right here, guys, this is going to probably be the middle leg again. Then over here, hypotenuse. Okay, so we do have a missing leg, which means that you're going to have to find the missing leg before you can find your ratios. All right, so let's go ahead and let's do number 2. Let's go ahead and do number 2. All right, are you guys ready? Did you flip to your next clean page? All right, worksheet 1B, number 2. So guys, before you dive in and do your Pythagorean's theorem, make sure you know what leg is missing. All right, what leg is missing? All right, I just drew that all wrong, didn't I? All right, here we go. And by the way, I just noticed something. Nothing is proportional. That 4 and that 12, those look like they are the same length. So you can't use side lengths on this. All right, so we have alpha as the variable for the angle. Sometimes they do different Greek letters. All right, guys, so here we go. We're looking for the hypotenuse. Is that right? Mm-hmm. You have to find it before you can give any of your ratios. All right, so we are looking for the hypotenuse, so we can just dive in. A squared plus B squared equals C squared, looking for the hypotenuse. So 12 squared plus 4 squared is C squared. Please follow order of operation. All right, add last. Always do your powers. Always multiply, divide, and add last, okay? So we have to square those numbers before we add. So here we go. 144 is 12 squared. 16 is 4 squared. This is our C squared. All right, find the sum. Is that 160? All right, 160 is C squared. Now, we're going to have to dig back to your good old algebra days. We have to simplify the radical. We have to simplify the radical, okay? Now, I'm going to try to do it exactly the way we've done it. We did it back in Algebra 1. In Algebra 1, guys, we used prime factors. 2, 3, 5, 7, 11, 13, 19, and so forth. Remember how we would take that 160 and I use the L. The first prime that you always want to try to use is 2. If the number's even, always use 2. All right? And you get 2 into 160 is 80. And as long as you can use 2, okay? All right, then 40. 2 again, you get 20. 2 again, you get 10. 2 and then 5. And the process is done when you get a prime, and 5 is prime. Now, the point of all of that is so that you can locate the pairs. Perfect squares are pairs. There's a pair of 2's. There's another pair of 2's. Now, this is what's under the radical right now. All of that is under the radical. If a pair of 2's is under the radical, it's technically a 4. What's the square root of 4? 2. So a pair of 2's comes out of the radical as a 2. That's technically a 4. Square root of 4 is 2. Now, the other numbers, the 2 and the 5, did not get paired up. So they stay under the radical. Okay, you just brought out a 2 and another 2. And you're leaving the ones that do not get paired up. The 2 and the 5, 2 times 5 stays under the radical. Okay? All right. Now, can you guys tell me what the simplified radical is? What our answer is? Multiply these back together. 4 on a square root of what? 10. That's our C value. That's our hypotenuse. So we're going to take that and we're going to go back up. And you're going to write up there with your hypotenuse, you're going to write 4 square roots of 10. And now you're in business. Now you can find the ratios. Okay, here we go. Let's find our ratios. All right, are you guys to the point where we don't have to write the adjacent and the opposite and all of that anymore? Can we just go straight to our numbers? All right, let's just say it. So what is cosine? Adjacent over hypotenuse. Here we go. What's the adjacent side? Maybe we should stop and go back and identify that. All right, let's go back. Here we go. We know the hypotenuse is our 4 square roots of 10. What's the 4? Opposite. And then what is your 12? Adjacent. Okay, let's do that much at least. Here we go. Cosine of theta. Adjacent. 12. Hypotenuse. 4 square roots of 10. All right. We need to rationalize that denominator. Y'all go ahead and rationalize the denominator. Yes, ma'am. Okay. All right. Marissa, you'll have homework tonight, but just text a friend or something. Find out what it is. Depends on how far we get right now. Okay. Hey, guys, we have to rationalize this denominator. Multiply top and bottom by square root of 10. Multiply top and bottom by square root of 10. What do you get when you multiply square root of 10 and another square root of 10? Is that square root of 100? But that is 10. Okay, you already had a 4. Now you have a 10. They multiply and they make 40. Good job. They make 40. I see a fraction we're going to have to reduce. Now, in my numerator, I have 12 on a square root of 10. I'm good with the square root of 10. I can't do anything else with that. But my 12 and my 40 are both divisible by what? What's the largest number that will divide 12 and 40? 4. Good job. Divide by 4, top and bottom, and what do we get? 3 and 10. So 3 square roots of 10 divided by 10. Okay. Now, you guys, this one is actually a real trig problem. The others we worked have kind of been Mickey Mouse, but this one's actually the real deal. So, all right, here we go. Sine of theta. Come on, hang in there. We're almost done. Hang in there, guys. All right, what's sine? Opposite over hypotenuse. 4. Opposite is 4. Hypotenuse is 4. Square roots of 10. Let's go ahead and knock out those 4s. Go ahead and knock them off, okay? All right, what have you got to do? Multiply top and bottom by square root of 10. What does that give us? Square root of 10 over square root of 100. But what's the square root of 100? 10. You're done. All right, tangent of theta. If the two fractions that you just gave have the same denominator, and they do, all you have to do is pull the numerator from your sine answer and the numerator from your cosine answer. What's the numerator in your sine answer? Square root of 10. What's the numerator in your cosine answer? 3 square roots of 10. Guess what the square roots of 10 do? Cancel. You have an understood 1, and then you have a 3, so 1/3. Good job. Thank you. All right, now let's give the reciprocals. Here we go. All right. So what is the reciprocal of cosine? Secant. Secant. So all we have to do is flip the fraction for secant. All right, so 10 goes up. 3 on a square root of 10 goes down. All right, tell me what to do. Multiply top and bottom by square root of 10. What does this square root of 10 multiply this square root of 10 and make? Do they make 10? Okay, do you guys see a 10 in the numerator also? And then you're telling me I've got a 10 in my denominator? So this 10 and that 10 will what? Good. What does that leave in the numerator? Square root of 10 and the denominator. 3. Good job. Thank you. There's your secant answer. All right, cosecant. CSC, cosecant. All right, look back up. Let's go here. Okay, guys, remember me telling you that you can use either this fraction or the final answer you got right here to flip. Which one of these do you want to flip? And when you do, you want a numerator up top. You don't want a numerator in the bottom. You guys see how if we flip this one, we're going to put that square root of 10 back down. But do you guys see how if we flip this one, square root of 10 goes up and 1 goes down? So I'm definitely going to flip that 1 over the square root of 10 because that just makes square root of 10 go up. He's understood to be over 1, so he's done. Okay. What do you get when you flip that tangent answer? Thank you, 3. Awesome. Okay, here we go. Write this down for me, please. We need to do a few of these, guys. Here we go. Let's see, tonight, worksheet 1B. Let's do, let's just do 3 and 4. How's that? And you guys do these for homework, and then we'll probably end up doing another one in class to make sure you have it. Okay? Someone can text that to Marissa for me, please. Okay, very good, guys. Thank you.